Hello guys, and welcome to the channel. Today we're going to continue about the continuity in mathematics and what is the three-step continuity test. I made two exercises as an introduction to this topic and a little bit theory right there. Okay, let's begin with the theory first. To prove if a function is continuous at some point, then we have to do the three-step continuity test that goes from A to C. The first point, A, says that f of A must be defined. The second, B, tells us that the limit when x goes to A of f of x exists. And to prove that this limit exists, then we have to see the limit from the left and the limit from the right. So the limit when x goes to A from the left of f of x must be equal to the limit when x goes to A from the positive of f of x. And the final step is the limit when x goes to A of f of x must be equal to f of A. Okay, let's begin with the exercise 1 in order to understand better that theory. So we have a function here, f of x, that is x for x greater than 0 and x squared for x less or equal to 0. And this exercise asks us that is this function continuous at x equal to 0? Okay, we have to do the three-step continuity test. For the first, to see if a function is defined at x equal to 0. Well, f of 0 is equal to 0 if we put the value of 0 at x squared, and that is defined. On the second step, see the limit from the left and from the right. We have the limit when x goes to 0 from the left, that is in the positive, is equal to 0. If we put the value of x equal to 0 to the limit, then is equal to 0. And the limit when x goes to 0 from the left, then we have the x squared for x less or equal to 0, and that is equal to 0. So the limits are equal to each other, and the limit does exist. The third step is also fulfilled because we see that the limit when x goes to 0 of f of x is equal to f of 0. Move on with the exercise 2. We have the f of x is equal to x plus 2 for x greater than 1 and x cubed plus 1 for x less or equal to 1. And exercise says that do the continuity test. Okay, let's do the three-step continuity test. Then the first one is that f of 1 is equal to 2, because if we put the value of 1 in this function here, x cubed plus 1, that is equal to 2. Now let's see the right and the left, the limit. From the right and from the left, we have the limit when x goes to 1 from the left side of x cubed plus 1, that is equal to 2. And the limit when x goes to 1 from the right of x plus 2, because greater than 1, is equal to 3. So these limits are not equal, and the limit doesn't exist. If the limit doesn't exist, we have said in the theory that this function, it's not continuous. And for the third step, there is no need to do it because step 2 is not fulfilled. And we can say that this function is not continuous at x equal to 1. Thank you guys,